Hello, everyone. Good evening, and welcome to One Mark Solution. Today, we are starting with yet another episode for assertion and reason based questions for class 12 chemistry. And today, we are going to discuss coordination compounds. This is me, Manisha Sharma from Ma Today School, and you can check the video on this link. Let's go ahead and go with the first assertion statement. The first assertion statement says EDTA is used to treat lead poisoning. Now, lead poisoning is, of course, a very complicated disease. And the reason uska wo deta hai that EDTA forms very stable complexes with lead. So basically, EDTA is definitely used to treat lead poisoning. And the reason is also correct. That's because since it can bind with lead, so what happens? EDTA is water soluble and it's a stable complex. So as soon as there is lead poisoning happening in the body, it binds with EDTA and automatically gets out from the body. And so we have assertion and reason true, and reason is explaining the assertion pretty well. Second assertion that we have is colored complexes become colorless once the ligands are removed. Now, what is the purpose of ligands? Now, ligands are the substances which combine with metals and ultimately give color to the complexes. Now, the reason for that is that the metal has got unpaired number of electrons, and these unpaired electrons jump to the higher energy level, come back, and automatically give the color. The DD transitions are not possible since d orbitals become degenerate. That's absolutely correct. So once you remove the ligands, right? So what happens? There is no binding happening. Since there is no binding happening, the electrons are not able to jump to the higher energy level. Since there is no jumping from here to there is no movement from one d orbital to another d orbital, the DD transitions are not happening. And since they are not happening, of course, the color is not visible. So assertion is true, reason is true, and reason is the correct explanation of assertion as well. Third statement that we have is carbon monoxide forms low spin complexes with metals. So carbon monoxide here, carbon monoxide has a very peculiar character, I would say. It is carbon monoxide as well, and it exists as carbonyl also. So somewhere it's very flexible and it's very flexible and gives you a lot of range of variation. Now the reason says that carbon monoxide is a neutral oxide. Now low spin complexes are every time this carbon monoxide is, of course, neutral in nature. And every time it's binding with some metal, it's forming a metal carbonyl bond. Reason is that carbon monoxide is a neutral oxide. That's correct. So reason is definitely correct. Assertion is also correct. But why is it forming low spin complex is not being explained properly. And why is it forming low spin complex? Because carbon monoxide or the CO, the carbonyl, is a strong ligand. So strong ligand means they pair up. Once they pair up, they become low spin complexes. So here assertion is also true, reason is also true, but reason is not able to explain assertion pretty well. Next, we have the fourth assertion that we have is carbon monoxide is a deadly poison. We agree to this that yes, it is a deadly poison. And reason is carbon monoxide can form strong complexes with hemoglobin, which is absolutely correct. Hemoglobin consists of iron in it. When carbon monoxide or carbonyl binds with iron, it forms a very strong metal carbonyl compound. And since it's poisonous, it binds with hemoglobin and ultimately spreads the poison or spreads that impact in your entire body. So assertion is true, reason is true, and it is pretty explaining the assertion as well. And that is why we'll go with option A. Fifth statement that we have is tetrahedral complexes cannot exhibit geometrical isomerism. Let us understand how tetrahedral complexes look like. You have this metal, you have ligand, you have ligand, you have ligand. So you have metal and ligand complexes like this. This is tetrahedral. Okay. Now, if you have same ligands on all the sides, what are geometrical isomerism types of? They are either cis or they are trans. So if the two ligands, similar ligands, are on the same sides, they are cis, and if they are on the opposite sides, like I'm showing right now, then it is, trans in nature. So it cannot exhibit geometrical isomerism because if you take the mirror images, then you don't get that much of variation. Reason says tetrahedral complexes are chiral in nature. Now, what is chiral in nature? chirality comes from the carbon-based compounds. You understand it from the organic compounds. If all the species are same on the four sides of carbon, then they are known as chiral carbon. If they are different, then we call it. If they are same, we call it achiral, and the opposite goes for it. So that's not true for tetrahedral complexes, and that is why assertion is true, but reason is false. Sixth statement that we have is an octahedral complex with two bidentate ligands is always optically active. Now, bidentate ligands are something like, ethane 1,2-diamine. This is bidentate ligand. So octahedral complexes will have around 6 ligands around them. If there are, bidentate ligands, then probably you will have one here, two, three, four, and five, six. That's how the octahedral complex looks like. Now here, octahedral complex is not always optically active if we talk about bidentate. Because why is it so? Suppose I take my cursor here, and I have En here, I have suppose CO here, and I have NH3 here. Now, this cannot be optically active always, no, because if you take the mirror image, you will get this, right? So it is superimposable. That's okay. But if you do not have something like this, if you have, all three same, then also it's superimposable. But if you have only, two bidentate and you have two different kind of ligands, then it cannot be, optically active. The reason is the cis isomer of the octahedral complex is chiral. That's absolutely correct. So here we go with the assertion false and reason true. Seventh assertion that we have is ionization isomerism is shown by complexes having ambidentate ligands. This is not correct, because ambidentate ligands are the ligands which can join with each other from two sides, like CN, and it can also join from NC. Right, so this is ambidentate ligand. Now, if I have metal here, if I there cannot be an ionization isomerism happening. There you will have probably coordination isomerism happening, because now the metal is coordinated through carbon and here the metal is coordinated through N. So the coordination of the metal and the ligand is different, and that is why ionization isomerism is shown by this is absolutely wrong. So we go with the D option, which says that assertion is false but reason is true. 8, we have the color of a complex changes when one ligand is replaced by another. That is, not correct, because it depends on what is the nature of the ligand, how active that ligand is, and how much it is binding with the metal. The reason is the magnitude of the orbital splitting is decided by the nature of the ligand. That is true, because if the ligand is ambidentate, if the ligand is bidentate, if it is unidentate, so of course, d orbital splitting would be affected and pairing would be affected. So here again, assertion is false, but reason is true. Ninth statement that we have is FeCN63 minus is more paramagnetic than this. So for this, you can simply go by the VBT theory. I hope you understand this. And Fe, you get the oxidation state as +3. Fe is 26 in number. So if I take Fe3 plus, it becomes 3d5. And I have 5 unpaired electrons here. If I go with Fe, F6, 3 negative, I again get Fe3 plus, and I will have, but Cn here is a strong ligand, so pairing of electrons will be done. The fluorine here in Fe, F6 is a weak ligand, so the pairing won't happen. So on this basis, we have assertion as false, assertion as false. And the reason here has more number of unpaired electrons, that is true. So if that is more unpaired of electrons, then Fe, F6 should be paramagnetic, because more number of unpaired electrons means more paramagnetism. So that's the answer. That assertion is false, but reason is true. 10th is CONH363 plus is an inner orbital complex, and CONH3X63 plus forms an octahedral complex. So reason here again is true, and assertion also here is true. For that, again, you will have to calculate the oxidation state of cobalt, and when you calculate the oxidation state of cobalt, it comes out to be 3 plus, because amine is neutral. So the pairing would happen because NH3 is a strong field ligand. And when the pairing is happening, you are having the hybridization as D2sp3. So inner orbital complex, because there are 6 amine octahedral complex. So assertion is true, reason is true, but it is not able to explain it properly. So we go with the D option. So that's all for this chapter. You can check the videos and you can check the channel on this link. And that's all from my side today. We will come back again with another chapter. Thank you so much for attending.